SELIP design, manufacture and test RFP products. RFP spray banks since 1961. Much of the energy used in the world over the coming decades will be provided by burning fossil fuels. This is thanks to the vast quantities of fuel available in large areas of the world, the low costs involved in energy conversion, and the reduced ecological impact which can now be achieved using the latest state-of-the-art systems. A plant for converting the thermal energy produced by coal combustion into electrical energy with a 500 megawatt capacity requires an investment of around $120 million. Coal power plant. Often the difference between an efficient and profitable system and an unreliable, inefficient and consequently unprofitable system can be found in the heart of the fumes abatement system. During the scrubbing cycle, an abrasive and corrosive fluid known as slurry flows through the piping and is forced through the spray nozzles. When the slurry comes into contact with the flue gases, a combination reaction occurs, removing approximately 99% of the pollutants produced by the combustion process and obtaining gypsum as a waste material. The failure of these components, known as spray banks, as well as harming the environment, also lead to system shutdowns with subsequent negative effects on profits. According to a study carried out by Sargent and Lundy in 2003, failures in FGD systems are caused by 21.5% inadequate material selection, 14.3% process modification, 32.1% quality control failures. This proves that a significant number, approximately 32.1% of failures, are due to poor material selection. In other words, the use of materials with poor chemical or mechanical properties, or which are simply not suitable for this type of application. Causes of breakages are slurry abrasion action. Abrasion affecting the external piping caused by the jet of fluid from the ceramic spray nozzles. Abrasion affecting the internal piping surface due to the flow of slurry containing abrasive particles. This effect is amplified if there are section variations, sharp and unjoined edges, or poor quality materials. SELIP has adopted a design and construction technology aimed at minimizing these problems. Today's solutions are the result of years of experience working with some of the most important user companies in the world since the 1980s. The internal joins and curves are specially designed to maintain the laminar flow of the slurry and stop the particles in the fluid from violently and repeatedly hitting against the piping walls. The internal and external liners are made from top-quality materials, anti-abrasive agents and components which have been selected and optimized through years of comparison testing. Thermal action from hot gas. Delamination, or the separation of the glass layers which occurs following an increase in the volume of air between the various layers in the presence of heat, has been totally eliminated by using a 100% hand layup process and high mechanical strength materials. This makes it possible to achieve relatively slim thicknesses and layers which are far more compact, as the laminate is made up of uniform layers. Obviously, the manual skills of our workers acquired over years of experience are another crucial factor in obtaining a 100% defect-free product. FRP clamp with internal sliding liner. To reduce strain, SELIP recommends leaving the spray banks free to expand longitudinally by using special clamps which still prevent vertical jumping movements. Steel moulds. To build spray banks which combine all these properties, SELIP has adopted patented technology which makes it possible to eliminate joints and critical points and obtain a monolithic part. On the basis of present knowledge, we maintain without fear of contradiction that this technology is the best currently available. The coupling between the spray banks and spray nozzles provide the designer with ample autonomy of choice. Flange nozzle with bolts and gaskets. Flange nozzled with Victorlic couplings. Here are some of the projects we have been involved in. Gardanne, France. Yunfu, China. William Station, South Carolina, USA. Shanwei, China. Shajiaoxi, China. Puławy, Poland. Opatowice, Czech Republic. Oak Grove, Texas, USA. Marica 2, Bulgaria. Maoming, China. Luoding, China. Los Barrios, Spain. Houchet, France. www.selip.it. info@selip.it